We are now at a teaching video A on trigonometry. We'll look at the transformation of trigonometric graphs today. The first group, basically, we just examine the basic graph of the sine, cos, and tangent. If you look at this particular graph, y equals sine theta, all these theta values are in radians. So if you put in a 0 into sine theta, you get a 0. If you put in pi on 2 into sine theta, you get 1. So the rest of the value like pi put into sine theta, you get 0. Put 3 pi on 2 into the sine theta, you get a negative 1. You put 2 pi into sine theta, you get 0. So over here, the highest value of sine theta is 1. The lowest value is negative 1. If I join up this graph, it's a nice curve. So that is your sine curve. So it's important to label it y equals sine theta. If I ask you for the range of the graph, then it will be between negative and 1, inclusive of the negative 1 and 1. This will be your range. Basically, what it means is the vertical values. The lowest, negative 1, the highest, 1. So in between, you find y values as well. If we are looking at the domain, then the domain I've specified for each of these situations would be between 0 and 2 pi. Now these values are in radians. So the equivalent degree value would be 0 degrees, 360 degrees. So I have chosen for all these graphs that I will show you in this segment of the video, the domain will be from 0 to 2 pi only. So if I'm asking also for the amplitude, amplitude is measured from the horizontal axis to the highest point. The amplitude is just 1. And you can see from the horizontal line to the lowest point is also 1. Next, if I'm talking about the period of the graph, then this is a complete cycle of the sine curve. So the period would be 2 pi. So write that down. Amplitude first will be 1, period is 2 pi. This is where you find in one period a complete cycle of the curve. Now for your information, if I continue to sketch the graph, you will find this pattern of the curve repeating itself. So it's a continuous wave. of the sine curve. That will apply to the cos as well as to the tangent. Next, we are looking at y equals cos theta. So, if I put in 0 into cos theta, I'll get 1. If I put in pi on 2 into cos theta, I'll get a 0. If I put in the pi value into cos theta, I'll get a negative 1. I put in 3 pi on 2 into cos theta, I'll get a 0. If I put in 2 pi into cos theta, I get a 1. So again, the highest point, the highest value of the curve is 1, lowest is minus 1. If I join up all these points with a curve, it will look like this. So this is the cos curve. Y equal cos theta. You find why somehow, even though I'm using a freehand here to sketch the curve still look reasonably smooth. The reason mainly is because of the grid line. It is important when you draw or even sketch trigonometric graphs to have 4 parts, 0 to pi on 2, then to pi, then to 3 pi on 2, then to 2 pi. There are 4 parts that you have to consider. Of course, if you link it back to the 4th quadrant, this will be your 1st quadrant, 2nd quadrant, 3rd and 4th quadrant. So the 1st quadrant is between 0 and 2 pi. For degree form, it will be 0 degrees to 90 degrees and so on. So that's why the 4 portion is closely linked to the 4 quadrants. You can see in the 1st quadrant, the cos values are positive. When it goes into the 2nd quadrant, the cos values are all negative. Then in the 3rd quadrant, still negative. By the time it goes to the 4th quadrant, all the cos values are positive. So you can link back to the 4 quadrants of angles. Next, we look at y equals tangent theta. If you put in 0 into tangent theta, you get a 0. The moment you put pi on 2 into tangent, your calculator will register mathematical error. That's because that curve there will never touch this line. So you will have a curve that goes like this. So if you put in pi into tangent theta, you get a 0. Now, since when you put in pi on 2 into tangent theta, you get mathematical error, it will also mean this, that it will be a curve that goes very close to pi on 2 but never touching it. So it is like this. Now if you put in 3 pi on 2 into tangent theta, again you get mathematical error. So suggesting that there is a line that goes very close to 3 pi on 2 but never touching it. So since the curve will never touch this line, vertical line, 3 pi on 2, But if you put in 2 pi into the tangent theta, you get a 0. It means this. So, the graph of tangent theta looks like that. Over here, you will have noticed that there is no limit for the y values. This curve stretches all the way infinitely upwards, and this part infinitely downwards. So there is no limit for the range, but still the domain is from 0 to 2 pi. If you are looking at the period, you can see this portion repeating itself. So basically, what you see in the first 2 quadrants is repeated in the third and the fourth quadrant. So the period will be pi. So every pi, you get a repeat of tangent theta graph. So this is one of those graphs that is difficult to label because it's discontinuous, but you just put an arrow to any one part and call it y equals tangent theta. Now with the basic graph, now I introduce some movement of the graph. So the first case I'm looking at is y equals f bracket theta plus minus a. Now the f bracket theta is just some basic graphs we are looking at, sine theta or cos theta or tangent theta. But the a is a constant. So in this case, you notice that the a is a plus 1. So what does the plus 1 do, really? So let me just sketch for you the basic graph. Name the axis first. 1, 2. This is minus 1, minus 2. So the basic graphs will look like that. But with the plus 1, what it does is, instead of at the 0, now it's there. Instead of at 1, it's going to be at 2. Instead of being on the axis, move 1 upwards at 1. So it goes to show that every part of the graph is increased by 1. But I'm only taking critical points that theta equals 0, theta equals pi on 2, and so on. And that will be enough for us to just sketch a proper graph of sine theta plus 1. So this graph here is y equals sine theta plus 1. And this one here is just y equals sine theta. This is the basic graph. So it's important to know your basic graph, and to work out all other graphs, we basically try to understand what each part of the expression will do to the basic graph. So to describe the transformation, I would say y equals sine theta is shifted 1 unit vertically upwards. So what does the plus 1 do? The original graph is shifted 1 unit vertically upwards. So if you can move this graph, it is just 1 unit upwards. So you get this effect. Next, we have this case, minus 1. If plus 1 is to move the graph upwards, then minus 1 will actually move the graph downwards. So let me just sketch for us the original graphs, the graphs of y equals cos theta. So this is 1, 2, minus 1, minus 2. The original graphs so that graph is just y equals cos theta. So to move it downwards from 1, now it's down to 0, 0, minus 1. And you can see all the points reduced by 1 vertically. So now the actual graph that we need to sketch that will be y equals cos theta minus 1. So the description of the transformation is y equals cos theta is shifted 1 unit vertically downwards. So let's look at the next groups of graph, a different transformation. This time you see there is a negative in front of f bracket theta. Again, f bracket theta is referring to the graphs, the basic graphs like y equals sine theta, y equals cos theta. The negative here will do one thing. Let me just sketch for us the basic graph. That is your y equals sine theta. So at this point, sine 0 is still 0. So negative of 0 still gives me the same thing. But sine pi on 2 is going to give me 1. So 1, but with a negative in front, now I have a point here. Negative 0 is still 0. Here at this point I have a negative 1. So if I have a negative 1, I will have a positive 1. Negative 0 is still 0. So if I just draw that graph by joining all the critical points, you have a sense that that original graph with the introduction of a negative sign in front has actually been reflected along the theta axis. You can see this orange part is reflected onto the white part along the horizontal axis. So the descriptive part is y equals sine theta is reflected along the theta axis. So that's the transformation. For the next graph, y equals negative cos theta, I will sketch for us the original graph. So that is your y equals cos theta. That is a 1, that is a minus 1. So the 1 with the introduction of negative 1 will become negative 1. Put a negative in front of the 0, still there. The negative 1 will become positive 1. Negative 0 is still 0. The 1 here with the negative becomes negative 1. So to join those points, so that is the y equals negative cos theta. Again, you can see the orange part is reflected onto the white part along the horizontal axis. So I have here y equals cos x is reflected along the theta axis.